Hi, this is week 7 graded assignment for statistics 2. So, our first question here is let x1, x2, x3 be three independent and identically distributed random variables with a given mean and variance. So, the three, of course, the means would be same for identical distributed, and here A, B, and C have the individual sum up to 1. So, we can write their mean as mu and mu and mu, right? So getting to the point, to find the variance here, we will use the formula variance of ax is equal to a square variance x. Perfect. And for the independent identical distributed random variables, we already know that variance of x1 plus x2 plus x3, wait a minute, x2 plus x3 and whatever, let us say xn, would be the variance of individual random variables, which would be variance of x1 plus variance of x2, and this goes up to variance of n, right? So let us solve the questions here. So wait, yeah, variance of a would be variance of x1 by 3 plus variance of x2 by 3. This goes right according to the formula I told you before. Yeah, variance of x2 by 3, yeah, perfect, plus variance of x3 by 3. Also, it is given that the variance for x1, x2 and x3 is sigma square, so we can replace it and use this formula. So 1 by 3 would be 1 by 9, so we can remove this. It would be 1 by 9 here. Again, it would be 1 by 9, so I'll be taking the whole. 1 by 3 would be removed and we will get its square, which is 1 by 9. So we can write it like this also, 1 by 9 into variance of x1 plus variance of x2 plus variance of x3, right? So we know that this all sum up to 3 sigma square. So again we will be simplified with a easier solution, which would be 3 sigma square, and this would be sigma square by 3, or we can write it like 0.33, right? 0.33 sigma square. For B it is pretty easier. Variance of B would be 0.01 sigma square plus 0.09 sigma square plus 0.36 sigma square. Basically I am using the formula here. So variance of 0.1x would be 0.01, so into the variance, right? 0.3x would be 0.09 sigma square, right? Here let me write it like a wait a minute, yeah, a square sigma square. We can simplify it more. So 0.6 would be 0.36 sigma square. So variance would be B would be sum of all these, which would be 0.46. And similarly for this one, 0.4 sigma square plus 0.09 plus 0.25. So this would be equal to basically, yeah, 0.13. It would be 13 plus 25, 0.38. So variance of C is 0.38 sigma square. Yeah, so we can see that variance of B is highest, so and A is lowest, so this is the correct option. I hope you are clear with this. And the formula used here are pretty old formulas, right? We already did it in stats 1, so it would be pretty easy to use. Thank you. Now next question would be, a random sample of size 55 is collected from a normal population with a mean of 100. So, and the standard deviation is 5. So we need to find the variance of sample mean. So basically, the variance of sample mean is, let me write it like this, variance of sample mean is actually the variance of n divided by n, right? So this is the formula here. We will be using the formula. Standard deviation is 5, so sigma square would be 5 square, and n is 55, so we will get 25 by 55, which would be further simplified to 5 by 11, and we will get our answer as 0. Wait a minute, let me calculate it. 0.45. 0.45. Actually this would continue 4545, so I would recommend to write it like 0.45 only. The next question is, a fair die is rolled 200 times. Let x denote the number of 6 obtained. Find the bound for the probability that x divided by 200 differs from 1 by 6 by less than 0.3 using weak law of large numbers. Okay, so again I'll be using this notes. Let me clear this all. Is there a way to delete all of it? I don't think so. So let me create a new note. So first of all, for a single die, a fair die, probability of getting 6 is 1 by 6. So expected value of any trial, let us suppose it's xi, because the number of trials is 200. So for every 200 trial, the expected value would be 1 by 6. And similarly, the variance would be 5 by 36. Perfect. So let y denote the sum here. Let s denote the sum. It's up to you actually. So you can use whatever you want. S equals to x1 plus x2 up to x200, right? Perfect. So we need to find bound such that probability of x divided by 200 minus 1 by 6, it's mod here, divided by 1 by 6 is less than 0.3. This is the question here. So the weak law of large numbers gives the statement that probability of x, mod x, mod of x minus mu is less than, this number, the bound, let us say, I don't know the name, delta, would be greater than or equal to 1 minus variance upon n into delta square. So this is our weak law statement, right? So using this, we can say that this here whole statement would be equal to 1 minus sigma, here is sigma variance would be 5 by 6, so 5 by 36 into, then n would be 200 here, and sigma square would be 0.09, right? Perfect. So further calculating it, we will get the value 1 minus 5 by, this would be, let me calculate it, 36 into 200 into 0.09, it's 648. 5 by 648. Perfect. So the value will be 643 by 648. This is the maximum value we can get, right? So let me rewrite the whole part. Let me write it here. So this whole can be at most bound x by 200 minus 1 by 6, right, is less than or equal to less than 0.3 would be greater than or equal to 643 by 648. Perfect. So the correct option is this part, right? It's at most, wait a minute, it's at least here, yeah, at least 6. Yeah, this one is correct. So the next question,